Hey guys, John Grimsmo here, bringing you a bit of a different video than what I've been doing in the past. You see, back in the day, which was a Wednesday, Eric and I used to be quite into working on our cars and building things and turbocharging and custom engine management and just really having fun playing with cars. This was before knives, before machining even. We used to just mess with cars all the time. That was our thing. That's sort of faded away, but we still got the cars that we messed on a whole bunch, and they're all crazy, weird, modified stuff, and we're still driving them, and now it's time to do some maintenance, aka replacement / upgrades. So anyway, this is what you normally see from the shop, but here we have small intercooler. Anyway, this is Eric's old engine, which is one that I rebuilt, completely blueprinted from the ground up about 6 or 7 years ago. And it's got low compression on one cylinder, so something's wrong, like there's a cracked piston or something, I'm not sure. It still drove, but it smoked like crazy and it stunk and it's just nasty. So that came out, and then we're just putting in a real quick junkyard engine, which is surprisingly clean and had been rebuilt at some point by the factory. So this is going in Eric's Volvo 242 Turbo, 1983 vintage. So this is a 92 motor going into an 83 car. So it should be pretty good, just for a really cheap, quick junkyard swap. Anyway, the project I'm working on for this video is for the custom engine management that we used on the car. It reads the RPM signal from this trigger wheel. This is an EDIS trigger wheel, and using a custom machined pulley adapter thingy that my friend Dale used to make and sell. I don't know if he still does. But yeah, this engine is a slightly different kind of engine than this one. It's called a B23 from 1981 or 83 or something. This is a B230. So the crank pulley, where it goes, is a little bit different. This doesn't work on this engine. So I basically have to make a new one of these. I could buy one, but what's the fun in that? Always looking for a neat project. And yeah, I just want to see if I can do it. And doing it will be relatively cheap. So yeah, all I have to do basically is get this stuck onto the pulley there, to the crank pulley. So the first step is obviously measure it and design it. So I've got my calipers here, and I'm just measuring. This is sort of my process for making a quickie one-off part. I scope it out like this, all the measurements that I need, and blah blah blah. I'm going to be milling this part. Normally, like, this was turned on a big lathe, and I don't have a big strong lathe, so I think milling it will be a lot more fun. The part that I'm going to be doing is a big 5-inch chunk of aluminum, 5-inch by 2 and a bit. So I've got these soft jaws here with some Mighty Bite Talon grip clamps. These are cool for holding round parts. So I'm going to have basically 4 of those, one on each corner, and it goes here, and then the vice jaws goes in the vice and clamps them down. And these are relieved on the sides so they grip into the bottom of the part. Really cool clamps. I'm looking forward to trying them out. And so they're just going to grip onto the bottom 16th inch. The whole top is available for total machining and everything. So it's going to be a lot of metal removed, and it's going to be a lot of fun to do. So I'm going to design that part in SolidWorks and then get machining. So I'm getting the machine set up to machine this huge hunk of aluminum into a pulley adapter. Yesterday I machined a set of soft jaws with these pockets and threaded holes to accept these Mighty Bite Versa grip clamps. These are pretty cool little things because they have these teeth on the side, on both sides, that grip into the part, holding on to just 60 thousandths of material, like a talon. And these ones are really cool because you can rotate them to any position. So it works really good for holding round parts or oblong parts or just weird shaped parts. So I've got these rotated to fit exactly this 5-inch piece, and then you just crank down on the vise as tight as you feel comfortable going, I guess. I'm not quite sure what sort of torque I'm going to apply to that. I noticed if you go too far, it digs in and then it dents this and causes this to actually bend down, which will lift the whole piece up. But apparently these have a ton of gripping force and work really awesome, so I'm looking forward to finally trying these. Alright, so first thing I'm going to do is just clamp it down really good and then probe the sides and then the top, and that's going to be my datum point, my 0. And then just start drilling and milling, and I've got a whole ton of material to remove from this thing. It's going to be pretty awesome. Oh, thank goodness. I thought I just broke my camera. It is almost midnight, and I usually try not to work late anymore because I just work better in the daytime, but tonight I'm pulling a late nighter and a little sleepy, a little dumb. So I go to adjust the camera, and I think I was going to hit record, but I pulled this lever on the tripod. I don't know what I was thinking. Just one of those stupid things. So I pull this, and with the camera light, the thing's top heavy, and it just tumbles and falls face flat onto the ground, you know, 4 or 5 feet tall. So for the past 10 minutes, it would only focus on almost maximum zoom. I'd have to keep it almost all the way zoomed in for it to focus, and then it would have just a very tight focus range. And at regular zoom, at zoom out, it was just blurry everything. So I was like, crap, I think this camera's broken. I've only had it for a year. But miraculously, it seems to work fine now, so thank goodness. Stop being stupid. Alright, next up we're going to try this monster 1/2-inch end mill. I don't know that I've ever actually really used a 1/2-inch end mill on my Tormach yet. You know, I've used it for tiny little spotting and stuff, but never actually done a lot of work with it, so this is kind of a big deal for me. Off the top of my head, I'm doing 3,700 RPM. It's going to be, I believe, 10 inches per minute, 0.35 inches down, and then 0.1 inch step over, so 1 inch engagement. For 1/2 inch, 2 flute, carbide end mill, in aluminum. Here goes nothing. It sounded awesome. It's more than 0.1 inch engagement. Yeah, ton of chatter. I mean, it's a super long end mill. I can't blame it too much. Alright, so I've gotten this far so far. The wheel seems to fit just perfect. A little sloppier than I would like maybe by 1,000th or something, but I think it'll be okay. So I found that the trick to combat this long tool chatter is just to do a really shallow width of cut. So I did all of these at a 50 thou width of cut, going around and around, and that still chattered a little bit. I've got to pocket a huge hole in the middle here, and I'm going to do 25 thou width of cut, but at 60 inches per minute. So it's going to be scooting along pretty good. That should be pretty good chatter-wise and not take that long comparatively. So, yeah, it should be good. So I stopped that early because it was chattering quite a lot, enough to need earmuffs. And you can see not only a really rough wall finish, which is fine for roughing, but there's a cone in the middle where the end mill was dropping lower and lower and lower on every pass, because basically it slips out of the tool holder here and starts riding down, down, down. And that just happens with this style of tool holder if you rough it too much. So I'm going to have to either slow it down or take my width of cut even lower to combat that. No big deal. One more change and we'll see how it runs. So after suffering through about an hour of ear-splitting chatter with this super long half-inch end mill, I realized there are better tools to do this. For example, a face mill with some nice sharp aluminum inserts, or Tormach's toroid end mill with nice sharp aluminum inserts. It's a shorter tool, much more rigid, just way stronger design. It's not going to chatter nearly so much. So I did the first half of the hole with that half-inch end mill, and now I'm going to use that toroid and see what she does. I'm going to do a much bigger step over because I think it can handle it, so we'll see. Wow. So it takes more power to plunge it down. Hi! Watch the load meter up here. It's going to touch about now.
I know. Cool.
Well, that was just about 100,000 times better. You can see the difference in the cut there. I mean, the floor looks really nice. You can see the 4 steps for the toroid on the bottom versus the other one, and it did it in probably half the time, or even less than half the time, because I was doing an 1/8 inch step over, so an 1/8 inch width of cut, and then whereas the other one was 50 thou, and the tool is almost an inch diameter, 0.98, versus the other one's ½ inch, so it's probably, might even be 4 times faster. Wicked, wicked awesome. So obviously I'm left with the bumps because it's a round tool, but I'll go back in with the ½ inch end mill and I'll do one little cleanup pass and clean up the walls and everything. And then I've still got to go deeper still with a smaller hole. But yeah, right tool for the right job. Look at all these chips. Proves that sometimes you just got to know to use the right stuff. It's more experience and trial and error than it is, you know, the tools at hand, the tools available. So yeah, well, I'm extremely happy with that. That gives me a lot more faith for removing tons of metal like this. You just got to use the right tools, duh. So right now I'm just going back in with that ½ inch end mill and finishing the wall and the floor. It's lighter. Oh, that's cool. That's really cool, actually. So, if we look real close here, here are 2 of the bite marks from the VersaGrip jaws. There's 2 more. So they dig in pretty good. When I flip it over, I'm going to grip it from this top nub right here. So it is going to put bite marks into it. But if they're a problem, I'll just file them down and then they're not going to be an issue. If I was really fancy, I could make like soft jaws, where instead of the hard steel, I actually cut a big circle groove into the aluminum, and then the aluminum just grips it. But I got a lot to remove on the top side here too, so I need some grippage. Now, because I'm gripping on a smaller diameter this time, I need to rotate my VersaGrip jaws so that they match the new diameter. So I just loosen them off, and then they rotate fairly easily. The holes that I milled are pretty decent tight tolerance. So, funny story, bro. It turns out, with the way that my vise is set up, the workpiece is kind of far forward. I don't have enough travel to go that way. So the tool gets about to around here, and then it hits the limit switch because it just doesn't move that far. Crap. So I don't really have a lot of options here, except to maybe move the entire vise back on this pallet, drill 2 new holes there, and on the other side just move it all back, or I could rotate the vise 90 degrees and use this hole and then drill another one here or something. So those are the kind of the options I'm looking at right now. Not a big deal, just an extra headache that I wasn't planning on. Problem solved. Just rotated the vise 90 degrees, drilled and tapped 1 new hole right there, reused the same hole on the other side, and then we're good to go. I didn't take the time to make sure that the vise was perfectly trammed, like perpendicular, so I wrote a little note there, not square. That way I don't forget, because for this part it's round, it doesn't matter. I'm probing off the center hole anyway, so it's just round from the center. Well, here we have it, the finished part. Pretty sweet. Not my absolute best work, but for a first time part, first prototype, I'm only making one of them. I'm not going to make any more. So there's sort of not a lot of opportunity to optimize and improve on the one part. So you just kind of deal with all the, all the chatter inside. This part looks nice. But yeah, there's some resonance going on, some chatter. Outside looks pretty sweet though. That toroid cutter was just ripping through this at 70 inches per minute, taking off tons of material. Yeah, it fits. This is the trigger wheel. And then the 6 threaded holes around the outside will pinch the trigger wheel down so it doesn't move. And this fits right onto the hub, and boom, we have a trigger wheel adapter. Now the car should start with the new engine, hopefully. So, to break it down, this took way too long for me to make. Yeah, I probably put 10 hours into just the cam and machining side of it. Mostly machining. That's 10 hours I should have been spending doing something else. And then I start to wonder... forget that start to wonder part. I mean, obviously, this is a part that should be made on a lathe, and it would probably take a decent lathe operator, like, all in, under an hour, this thing would be done. But the good thing is I learned a lot about machining, especially machining a lot of aluminum on the mill, so that was good. I got information, I taught you guys, hopefully something, and yeah, I got a lot of machining experience and learned a lot of little tricks that will benefit me in the future. So the time was not completely wasted, even though it kind of felt like it at the time. And obviously this will get Erik's car going. And it's just a cool, pretty part that I can say I made. But yeah, if I were to do it again or do something like that again, I'd probably call up a friend who's got a big CNC lathe and be like, so you're gonna make that for me, right? So it was really sweet using HSM Works and all their really cool 3D toolpaths to make this part, because I could use that toroid cutter for all kinds of stuff. Like the whole top side, or this side of the part, was all done with the toroid cutter, and I just loved it. And then I just used the flat end mill to flatten this so it's nice and square. But yeah, the HSM Works toolpaths are pretty awesome, and it's a really good intuitive program to use. I'm really enjoying it. Can't wait to start making some knives with it. 3D machine knives, oh yeah! Well, so that's how I made this part. Thank you very much for watching. I'll see you next time. Bye.